We now move into developing an I2C driver, and this is actually really interesting because the driver is the one that will assemble all the different activities to create a transaction. So let's take a look at how that driver looks like. So in here I have the header file open and the CPP file open in here. So let's take a look at the header pretty quickly. So the first enum just tells me basically the register map. So the first one, I believe it's here. Okay, so the register map tells me the reading register is 0, and then the divisor is at 1, and then the last one, which is the write register for the command, and the DN is at 1. And in here I have a few of the command. Basically they're just straightforward, like encoding for the command, the different command, the start, the write, and the read. Okay, and here we see the functions that are necessary for the function of this particular driver. I have a constructor that basically and if you take a look at in here, we can take a look at the implementation right away. It just stores the base address and it sets the frequency to 100 kilohertz. So how does it set the frequency? It utilizes a function called set frequency. What does the set frequency does? It actually controls the divisor using that equation that we've seen, and it just basically stores it in that, or sends it to that particular offset in here, which is offset number 1, and it stores it. Okay, it does not need to remember this offset number 1. It's actually stored in here. Okay, and then I have a couple of other functions, which is end ready, and the ready basically just reads the ready signal in here to tell me that the controller is ready to do something else. And it's pretty straightforward, like decoding or like unpacking. I'm just reading that particular signal and then I'm unpacking it by shifting it by 8 and ending it by 1. Start is actually a command. If you think about it, it's actually in here. It just writes the word start into it. Basically, it just sends the word I start command in here. And of course, there's some sort of a busy wait in here, as long as like it's not ready. Okay, you just want to make sure you're not starting arbitrarily. The controller should be freely available to you. Okay, so it utilizes the ready. Restart is very similar. You're just basically doing a restart command and then the stop command in here. And these are basically generate the start condition, restart condition, and stop condition like we've seen before. And now we can see that we have a write byte. Okay, so the write byte itself, it actually writes a single byte. So it actually sends a single byte. And if you take a look at the implementation, it does the following actually. So it packs the data, if you think about it in here. Okay, so the accounting data here, it's actually data and that. Okay. And if you remember that this particular I2C here is actually already shifted by 8, so the enum already stores it in the correct location in here. So all I have to do is just store it, and basically I'm packing that and I'm just sending it whenever it's not ready. Basically you just wait till it's ready, and then you basically just send that data, and you wait till you're ready, and then you read the acknowledgement. So it's what's it doing is I'm assembling it now. So in here, I'm basically figuring out what the data that I want to send, what the command is, and then I do send it. This is what the write command is. So I send it to the slave, and then I basically stop till actually it's ready. When it's ready, I just need to read the acknowledgement, and the acknowledgement is pretty straightforward. You just read the acknowledgement by reading this particular value and figuring out this particular bit in here, and that's what you see in here. It's a bunch of ands and a little bit of a shift. Okay, and then you read. If the acknowledgement is 0, you just return it. If the acknowledgement is not 0, that means the slave have failed. You just return a negative number. And a negative number for an acknowledgement is an indication that this particular write operation has failed. Read is exactly or almost exactly the same. In the read, what we do is basically we say, okay, I'm going to have last, and the last is actually the acknowledged from me. Okay, so last, because read, you need to figure out when you're reading, you are reading, remember, it's like you might be reading 1, 2, 3, 4, 5, and then the last one is, that's if it's the last one or not. You need to figure out what type of acknowledgement you want to see it. If last is actually asserted, that means you want to send 1 to the slave so that it stops. If last is not 1, basically you need to send it to 0, and this is what we see in here. So we pack it with a command because I want to send it. And remember, last, all I care about is the least significant bit. I don't care about the other one because they're dummy. Then I write basically that, like I will read. Okay, first of all, I'll write into it the write register in here. Okay, and then, well, I'm doing the right, it's like here, the read. Okay, so we just packed it, and then while it's not ready, I'll just basically write into that write register in here, which I believe is this one. Okay, which assert the I2C, and then you continue, and then you read it, and that's it. Basically, that's pretty straightforward. Okay, and now the more interesting ones, which are the read transaction and the write transaction, and it just assembles a bunch of them. So if we take a look at what the inputs are, the inputs is actually the DEV, which is basically the device. It's actually the device address. So let me just show you what it's actually implementing. So the transaction is actually implementing this particular thing in here. So let's see, it's a whole transaction. So the read transaction is the one here at the bottom. So let's take a look. What's it doing? It actually needs the device address. Okay, it needs an array of bytes so that you can store the data you're going to read, and then you can tell it how many of these bytes you want, and this is num, and then you can tell it whether it should restart or stop at the very end, and that's basically what's it doing. So if you follow the code very closely, you can read what's happening in here. Actually, the device, I'm basically just shifting it by one so that I drop the least significant bit, and then I'm putting a 1 because I'm reading. This is basically that 1 in here, and then I can actually issue a start command, and then I will write that device address so that I activate it, and I can listen to the acknowledge in here and figure out if it acknowledged it or not. And then I'm going to basically read all the way num minus 1. Basically, this is all the way from 0 to num minus 1, okay? The reason why I'm doing -1 and not num is because the read byte in here, I want to acknowledge it. I want to acknowledge 0 and another 0 and another 0 and another 0, but the last one has to be different. So I'm going to do the read byte in here with a 1, telling it do not acknowledge the last one so that it can stop. And then you can see if it's a restart, you issue a restart. This basically it's reading that input in here. You issue a restart command. If all other than that, you stop. Okay, so you can restart the command, and restart does not, if you remember, it does just keeps the bus occupied. It does not relinquish the bus control to another master. So that's the difference. The write is pretty straightforward. It's exactly the same. You can see it. It's basically a start, and then you write the device that you want to, and then you go and you write all of them. I don't have that last one because I don't need to acknowledge. You can just keep it. And what it does, it returns that basic acknowledge, and it keeps summing them up. Like every acknowledge you receive, you keep summing them up, including the device. Okay, so eventually you return the acknowledge, and it includes the number of acknowledgements you received. So for example, I received 1, 2, and 3 in here, so it just returns that 3. And again, the restart and the stop condition are pretty straightforward.